Okay, now, in case you guys don't have my link where I share things with you guys, I want to share that with you now in the chat, and I think you should all be able to get to it. But if you can't, let me know right away. And going back to our chat, there we go. So everything I'm working with is from here, and I am in the Python lessons folder, and I'm doing, it's a collab notebook called Teaching on Classes, but I will share it right now. You know, it shows such small images. There we go. We'll do it this way. This is better. All right, great. Can everybody see that pretty well, or should I make it bigger?
It's perfect.
It's perfect. Okay, good. I'm gonna assume it's good. Good. All right. So last time I typed everything out as we went, but I think it'd be better if I just showed y'all this time. Now, to me, this first class right here that we're going to look at is the perfect example of the most basic class you can do. Oh, I meant, no, not that one. This one. Okay, so this is a super basic class. In fact, I call it basic. And I probably should have it capitalized. I don't always do things exactly according to Pepe, but there's a reason I didn't capitalize this one, because I don't have this one set up in a factory style. In other words, I don't have it set up so that you can create copies of it. In fact, if I did try to create a copy of this, it would just create a reference to it, and maybe I'll show you all that. I do show that in some other examples, but I just have two what we call attributes here, Hugo and Tom. And so if I run this and then check on those attributes, yep, I get them back. But here's kind of the fun thing about Python classes and the dangerous thing. I've got this defined, and I can go in and change that just like this. So if I run that and check again, whoops, I changed the values even from integers to strings. Now, the better way to do it for documentation purposes is to just define them in the class structure. Now, when we have functions inside a class, we actually just call them methods, because they're methods of working on the class attributes. So we've got methods and attributes. The data are the attributes, and the functions that belong to the class are called methods. So we'll redefine this whole thing now. And you can see, what's this going to do? It's going to say, and if you're not familiar with this, a very clean way to build up print statements. I do a F for format, and I start the string, and anytime I have curly brackets, whatever form this variable is in, it's going to turn it into a string and include it. So I should see Hugo and Tom are son and dad. And then here on more together, more is a calculation. And it's saying Hugo ID plus Tom ID, and then square that sum. And then it prints it out. So let's check that. Sure enough, it works. Now, Hugo did this fun article on petty officers. And when I showed using classes this next way, some officers came out of the woods, but it was actually a really good guy. I forget his exact name, but he pointed out some dangers with this, and he was absolutely correct. But I still like it to know that I can do this. So here I just have this empty class, and it's crazy to do it this way, but I can set these attributes on the fly, which is kind of like what I did up here. Okay, I just changed them on the fly. But if it's empty, I can even just set them on the fly. So I'll define crazy, and then I'll just start using it. But how am I using it? I'm even creating this function called funky, and then I'm applying a new method called silly to crazy, and setting silly equal to funky. And will all that work? I've done it outside of the original class definition. It all works fine. Now, why do I show this? Just so you know the realm of what can be done with classes. I'm not suggesting you do this, but I want you to see that you can access the attributes and reset them, and you can even attach new functions if ever you need it for some strange reason. And there have been some dynamic programming motivations for me to want to do that in the distant past, but I've never needed it since then. Okay, now you may have heard of the factory approach to Python classes. Now think about that. What does a factory do? Who's the most famous father of factories, Hugo?
Well, would that be the Toyota guy, or would that be Dale Carnegie, Andrew Carnegie?
In my opinion, it was Henry Ford.
Okay.
Because he mass-produced automobiles. Now, maybe the factory approach was already being used, but he applied it to making automobiles. And with the factory approach, we're building a class with the understanding that we're going to use it like a factory. We're going to produce new objects from it, but with specific attributes and the same methods that operate on those attributes, but we can change the attributes. So in this, when we do it that way, we always have an init function. Now you see these double underlines? This means that this is a built-in method to the object types in Python. And anytime you use this method, it happens when you first create an instance of this factory approach class. Now, there's a lot we're not covering today in this class. There are many functions that follow this same format that you can use and are readily understood by Python. But you can also create your own custom hidden methods. Now, trust me, you can still get at this one, even though I've typed it like it's hidden. It's just what we're saying when we do this is that I don't want the user to really use this. Now they could, if they looked inside, they could see this and get at it. They could even do a description on the class to find out what methods and attributes it has. But this is my way of telling the user, even if you do that, I intend for this one to only operate internally, not for you to call it. If you call it, use it at your own risk. But this init is special. So let's run this. We've got these 3 attributes, and one of them has a default value. When we do this, if we don't specify something for var3 will have this default value. So I've got method 1, and now because we're using the factory approach, unlike the above, where when we did basic, we don't have an init function and we don't call self, but however, inside I have to say specifically basic. From basic, get Hugo roll. From basic, get Tom roll. From basic, etc. But down here, this factory approach, as long as I keep passing in self, whatever instance name we use for factory, it all gets passed into here and it gets used. So here in method 1, I'm going to look to use the hidden method, but it's only going to be used if var3 is true. So let's see how that works. We've run this. Now let's create 2 instances. And I'm going to switch this up a little bit so we can see the difference. No, I'm going to keep them the same, because the real difference is I have true for var3 here and false here. So I set up these 2 instances. They're separate instances of factory. Now, when I print this one, I expect to see that extra print statement. And do I? Yes, I do. Your result is 3. And result from class method is 3. So this is what I set up from the value that was returned, but this is this function, method being called from within the class. All right, and if I do this one, we see, oh, I had var3 set to false, so it doesn't use that hidden method of printing. Now, result. Let's do for method 2. Yep, it does what we expected. It does the internal printing, and then we print the result that it returned also. But method 2, because it had false for that var3, it doesn't do the internal printing. So armed with this simple example, you can probably do 80% of the class work, the object-oriented programming work that we do in Python. Now, before I move on, are there any questions?
I know we touched a little of this last week, so I'm sure the guys are good.
Okay.
But we did not start with this the basic, because I know you always teach us how to be good programmers. So I didn't like start with the fact that Python class structure is not as regimented or as rigid as some other programming languages like Java. I know Java would never allow you to do this.
Exactly. That's
So,
exactly right.
right.
Yeah, that's exactly right. So now, and I actually feel like this Singleton approach is horribly underutilized, because there are many classes I create that I'm only going to use one instance of. Well, if I'm only going to use one instance, I don't need the factory approach. So what would a Singleton approach be? Well, I just start a class and I create attributes, and notice that I have no init method. Why? Because I'm not initiating an instance. That's why. But as long as I use this, now these are decorators, and there's a lot going on under the hood when you use these. They're quite fancy, but this is super elegant. Imagine that when you do this, Python is actually creating a wrapper around this so that it knows that, okay, you can use this CLS keyword now that you've said that. And
sorry,
that way,
that there was something I've been meaning to ask. I've not tried it before, trying to use a decorator like one line above where it is right now. I've been telling myself I was going to try it, but I don't know. I've not really gotten myself to try it. So maybe
understood.
Yes, a space between where the decorator is and the function begins, the method begins. Yeah, that's between line 6 and 7. Would it work?
We can try it, but I wouldn't want to do it, because I want to remind myself this is a decorator that affects everything below it until it ends, meaning it would be obfuscated. But let's run through this and then come back and test what you just said.
Okay,
that would be fun. That would actually be a fun experiment.
Right.
So for each of these methods, I have a your input, but notice I'm passing in this CLS. That way I can access without having to remember the name or have a long, like I might have a very long descriptive name for this class. I don't want to retype that every time. If this is a convention that we all agree to use in Python, and CLS is short for a class method, then this will be great, or for accessing class variables. This will be great. So this way I can access all these initial attributes, but notice I'm never going to create an instance like I did up here, where we say, oh, some new name is an instance of the class factory. Nope, it's just now, what a really good example of where you'd want to use this is when you're doing a class that has a lot of methods to control database access to SQL from Python. Now, if it's a general class where you're accessing a lot of different databases, use the factory approach. But if you know that you need a special class for each database, then create a separate class for each database and then do it this way. That would be an example. So I've got these methods. They're just simple because you guys can add the math. So we've got a plus, we've got a times, and then we've got a divide. But notice I have this fun assert statement. Assert says, I want you to make sure, make sure that your input is not equal to 0. And if it is equal to 0, tell the user you cannot enter 0. And then if we get past this assertion, then we can do the math and return the result. So let's define this, and Hugo, don't let me forget to go back and do our experiment together. So the first one, we expect 2. Why? Because we had these values set. Now, of course, from what I've already taught y'all, we could reset. So I put in an input of 1, but we could reset attribute 1 to 2 and know that we'd get a result of 3 here. Just know that you could do that. Now, the next one is 2 times 2, because that's the multiplication one. And then I'm going to see if I can raise that assertion. Oh, man, it didn't like that. That's good, because we don't want to pass that in. Oh, let me show you again. I blitzed that pretty quickly. Now, here's the message I entered for the assertion, but it's also giving us a trace back so we can find out where it went wrong. Oh, I put this in there. Why did I put 0 in there, etc.? Okay, print single class method 3. So that's with the division. We try it again without a 0. Works great. Okay. Now let's do that. I'm trying to create a copy of single, but is it going to act like a copy? Well, if I reset attribute 1 to 0.5 and use method 1, which, what does method 1 do? So the attribute 1 was 0.5, excuse me. So we're putting in 0.5 and it's going to add it to this new 0.5. But shouldn't it, see how I'm using the lowercase class, lowercase single and the uppercase single? Well, why am I getting the same answer? I didn't change it for upper class single. It's because this actually became a reference for this. In fact, just to show you what I'm getting at, let's see if single, the class lowercase single, equals the class uppercase single. Boy, I can't talk. Hey, they're the same. That means when I did this, I only created a reference for it. So why? Because it's just a single class. I can't create a copy. Now, I didn't test to see, could I have used the special case where I import the copy class. If we have enough time, we'll come back at the end and see if we can create a copy of single so that we can do this operation. But let's go try Hugo's experiment. Pepe. Okay, now I suspect, I'm guessing we'll get an error, but we might not. Nope, it works. So it's intelligent enough to know, well, I only see white space, so I'm waiting to attach myself to someone. And now I do not recommend this. I don't think it's as readable, but it looks like it's all going to work the same. So I think we're good. But again, just me personally, I don't like it. Now, help me remember, guys, we'll come back and try that copy approach later. Okay, now the container approach. And by the way, these are kind of standardized terms where we have singleton, where we have sorry for scrolling so much, I should do it over here, where we have the factory approach, the singleton approach, but the container approach, why do I call it that? Static methods always seemed a little strange to me because we still have to use the class name. We're not passing in self or CLS or anything like that. But why might you want to use this? Well, it may just be a collection of methods that you'd like to use. But there are some other cases where you have mixtures of static and class methods, and I'll show you that. Both, you can have mixtures of static, factory with self, and class methods. And there's times where that really makes sense. Be patient and gentle with yourself. It will become clearer when you would really want to use those. And I have one good example from Geeks for Geeks. When I was studying for this, I like Geeks for Geeks a lot. They use really clear examples, and sometimes their examples are more clear than what I was thinking of. So I'll just give them credit and use it. But in this container approach, this may just be a group of related methods that, hey, I don't want to instantiate a class. I just want to remember in some container, there are attributes and methods that I can use, and I can pass in other values too. So let's play with this one. Run it. And then sure enough, it works. But I've done this extra work of entering these names, but no big deal. And you'll see why. And a lot of this can be handled. Oh, well, don't do this. Only pass in your variables. You don't need to really access class attributes when you use this method. So again, one way to use this is a container. It can contain a lot of just individual methods. They kind of relate to each other, but you just want to remember that this is a group of related methods that do things. I've considered using this for storing and loading JSON objects, JavaScript object notation. Very powerful thing to learn. Very good way to store your data to file and bring it back. And there's a couple of methods that are really hardened and do a lot of great things. And I've considered, boy, it seems like it would be cleaner if I had no attributes and I just had a container and I called that class after importing it and just used it as a group of functions, really. But they're methods to that class because they're related. Okay, now a cool mixture. Like I said, stolen from Geeks for Geeks. Oh yeah,
sorry,
yeah.
Dad. Please, let's go back to that container approach. Okay, so technically, attribute 1, attribute 2, attribute 3 are properties or attributes of this class. But by putting this value equals to 1, is that technically not you instantiating it?
This is not instantiated, it's just an established attribute.
Okay.
Now, again, I love this approach when I have a group of functions that relate to one another, but they don't depend on one another. Like my example of storing and loading JSON objects from to file and from file. That would be an example of doing that.
Okay. And
Okay.
another thing that we've discovered is that this decorator at static method is common to the 3 methods that are in this class. So do you want us to, you want to show us the code for this static method?
Oh, you mean?
Yes, the decorator.
Oh, that would be worth a whole nother class.
Oh, I see.
To talk about decorators in general.
Mm-hmm.
Now, I have found some really good posts out there that explain what's going on under the hood and how to create your own decorators. And when you realize, oh, it would be nice to have a decorator for this function I just created for this class, or for just this function, that would be a good time to go learn them. But I would say 90% or more of your Python work can be done without decorators. Decorators are frequently used in web development work, Python frameworks for web development. But learning decorators is a worthy thing to go learn when you have extra time and you really want to go learn some more advanced Python concepts. Again, not impossible to learn, but probably worth a whole class. All right, now this cool mixture. So this is a Python program to demonstrate the use of class method and static method, but notice it's done inside a factory approach. This is a great little example to show you where this would be important. So, and I really wish I'd have had the extra time to create. You can still. Oh, I'm going to show it anyway, so it doesn't matter. But we could have attributes that belong to the class definition, but are independent from the factory, the instances. And I'll show you that in a minute. But here we have this class person, and we have an init method. And we pass in, when we create an instance of the class, we pass in these attribute values. But this class method, notice that it belongs to the class definition, not to the instance. So you can do some unique things that way. And this static method can be used independently. So why would you want to use this? Because you want this to be independent also of the instance and of the class. It really literally stands on its own, but it can be used either in this class, if you call it carefully, but more importantly, it's just getting, it's just doing a related function to this class. It's not necessarily doing anything particular for the class definition or the class instance. It's just a related function. So since it's not using any class attributes, it's not referring to the instance, but it gives us some important functionality. We call it static. So we instantiate and use that all at once. So person is Mayank, he's 21, and from birth year, 1996. So, oh, excuse me, yeah, 21. So from birth year, notice that we enter in a name, and from their birth year, we can get their age. I hope that's making sense.
Yeah, I see. Okay, I get it. The what you just printed was person one dot age. You didn't print the name. So that's why it was just 21 and the other from birth year. I get it.
Now, this example is probably old enough to where this was probably written 4 years ago. So that's why we're getting the big difference. And then, but is the person an adult? Well, we just enter the age and we get it true. Now, these are super simple examples. It's to reinforce the concept so you know when to apply them. Again, this is just a related function, but it's not interacting with the rest of it. So that's a good use of static. And this is something related to the class definition, but it doesn't have to belong to the instance. So that's why we do it that way. Okay. Now, by the way, all of these things can be done more complicated. If you follow this link, it'll take you to this page on Geeks for Geeks, and it'll walk you through more verbiage of the same example we just went through together, and even, just give you more text on it. So that's why I included it as a link here. Now let's talk about some basic inheritance. And then for more inheritance study, I really did like their page on inheritance too. So I think you'll be well served to look at that if you want. Boy, those ads are relentless. Okay, we've got some new factory. Now this is using factory from above. We already defined that. But I'm going to create a new factory, and look what I get to do. I'm just inheriting everything from factory and adding a new method. Wow. So let's make sure that works. I've got output 1 and 2, but it's the same stuff we did above. So I instantiate them both. Wow, I'm getting the same results I got above. So that means that we're just testing the inheritance. So here's, we're just going through those same examples we did above, but now I want to say, well, does my new method work? Yeah, works flawlessly. Isn't that amazing? And remember, we didn't have a divide function previously. And what's missing? I probably should have an assert statement to make sure the user doesn't pass in a 0, or I just let Python complain about it directly when I do this. But isn't that great? This can be very powerful when we still are using that original init method. We're just adding methods, and we can even we can put some getters and setters. That's where you have some methods to actually obtain the class attributes or set them. So if we wanted to reset any of these, we could, but I just find this immensely powerful because you can have a base set of functions, but then for some inherited things where you need to do things a little bit different, you can just add additional methods to that class structure. So that's very basic inheritance. And the reason I'm not trying to show more is this will get you there 90% of the time on inheritance. Yeah, you go.
Okay, Dad. Why is Python configured the way? I think sometimes I feel Python is very loose. because I noticed that for this inheritance, all you just needed to do was to indicate that this new factory was a child class of factory, and that was it. And you didn't need any super keyword to inherit, or you didn't use any, you didn't replicate the the init method down here. So why is Python that loose? Why is it why is it like that? Sometimes it gets worrying, it gets disturbing.
I've talked to really good software developers that have used C++, for example, or Java for years. And then they start learning Python and they feel like they were set free. But the simple answer to your question is because Guido set it up that way. And the Python community has only enhanced his original vision, his original vision, and has not tried to detract from it. So I think it's okay. It just, if you like it or not. Now, I've met programmers who hate Python because it's not strongly typed. I'm like, okay, it's fine. My attitude is, if I program clean and safe, my code will be clean and safe. I don't need your language to make me reinforce that. And if I want to cheat, it might be helpful to me in that moment. So don't, in other words, you go, it's really kind of expensive to put up lane dividers, physical lane dividers all over a city. It's cheaper to put up just white lines. But if there's a necessity for me to cross that white line, at least I can do it in an emergency situation. But most of the time, yeah, I'm going to stay within the lines. That's an analogy. Okay. Now, you go mention an important thing about inheritance. There is a super term, and I'm going to talk about that in a minute. Okay, an example of a creative, helpful trick that I like. Now, see this blend I have here? I have a class variable, a class definition variable, but it's not included in the init except right here. I'm actually saying, oh, and I should have done this. I just now realized that. I want to be able to get at the class definition variable of instances. Well, how could that be useful? I actually have found in the past, I needed to know how many instances of a class I had created. So look at this. This is instance 1. This is instance 2. This is instance 3. Well, that is pretty cool. This means that for all these instances we create that might be related, I can keep some super variables and keep track of things going on in each of the instances. Oh, that's pretty amazing. Now you mix that with super, very cool. So where to go next? Learn multiple inheritance. Well, what do I mean by that? Let's go up here again to inheritance. And you see how I've done factory here? Well, I could also add a second one. And there are ways to keep track of these multiple inheritances that are quite clear if you follow the good practices. Uh-oh. If you do a search, I just want to put a note here for y'all. Let's do a fun one. Python multiple inheritance. take the Geeks for Geeks link. They do a super clear job on how to do multiple inheritance. Very well done, in my opinion. But it's so rare that we use inheritance. And then again, it's even more rare that we need multiple inheritance, but it can be very useful so that you don't, once you get comfortable with it, you will love it. It's just that in my particular work, because I've been more of an artisan in my work, I've not needed to do things that way. And then how to use super. So the point that these bullets are to both of these points up here. 99% of what you need to do can be done without multiple inheritance and without super, but it could be that you get in a role where it's super important to know multiple inheritance and super. I was in a role where I was using super a lot, and as soon as I left that role, I kind of forgot how to use super. But it's not hard. It's just that I thought, oh, I don't want to muddy the water, because if you guys get good at using what I've shown you, each of these basic areas and this cool mixture and inheritance and little then tricks like this, but the main thing, create your own overflow. Oh, I meant for this. That's funny how it did that. Let me do this a little different. So I've told you about Thom overflow. If I were wanting to go get good at super and multiple inheritance, I would do it in Thom overflow. And of course I would have visited Stack Overflow and everything, but then Thom overflow is for my playing and experimentation. That's where I really learn things. That's where I push boundaries just to make sure I understand what I can and can't do. But I would just wait to learn these until you really need to do something. Okay, you go, your question.
Okay, Dad. So it has to do with that multiple inheritance. But what I would ask is it solid programming practice? Is it available in all other languages? Because it seems like somebody saying he has two biological fathers. So I'm now I've been trying to wrap my head since you said it around what kind of use case would you encounter in a program that would need multiple inheritance? So just
this is another really good site, Real Python, but we're going to go to Geeks for Geeks, and I'll go in and capture this and put it in our notes. So let's say a base 1 class and base 2, and then you do multiple inheritance. Well, they're just going through the principles here, but this example down here was so clear. Really loved it. Class 1 class 2 inherits from class 1. Class 3 inherits from class 1, but class 4 inherits from class 2 and class 3. And all of this works. There's examples of where you want it. Now, this is crazy. You wouldn't really do this. It's showing the principles and that it will work. But here's the real good example. No, we're still not there yet. Hang on. This one is. Is this it? Hang on. A super good example. This is just a longer article. Oh, this isn't the article I was remembering. Maybe it was the Real Python example, but there are cases where you realize it's good to create small type code that does specific things. Like you might be thinking, oh, I need to do this general thing. Well, no, it might be better that you had 3 smaller things that did all the things needed for that task you're thinking. And then later down the road, you may have those these smaller, tighter class definitions, and you realize, oh, I've got to do this new thing. Oh, I just can multiple inherit. But I wanted to show y'all, and I'm not remembering the great example I saw for it. Forgive my scrolling. I know that's annoying. Let me see if I can find it. Maybe it was in real Python. Let's just see, because they certainly have some. Okay. You know, I think it was in a, now that I think about it, it was showing multiple inheritance in just an inheritance post. So let me see if I can find it that way. I bet we can. And this is the one we were looking at earlier, I'm pretty sure. Yeah, this is going to be it. So come down here. Yes, this is the example I wanted to give y'all. And I think we've already linked this in the notebook. But here's base 1, base 2. We inherit those both base 1 and base 2. But notice what they're careful to do here. They're saying the init of this is going to call on both init functions and then add a new function, a method. So this, when you do multiple inheritance, this was the only reason I was kept digging for this link, is to show you it'd be really good if you did this. To be very clear about the combination of your inits. But again, I think it's going to be rare that y'all would want to use super. But if you're enjoying learning object-oriented programming in Python, we can do, I would be happy to do just a separate session. We can go over super together, and maybe we just learn it together in a very informal session. Because like I said, it's been at least 2 years ago since I've used it. And even then it was in a huge code base, and sometimes I had to create a new class that would use super. And I really solved some big problems with it. My teammates hadn't been able to do, but I just don't remember. It's so many lines, hundreds of thousands of lines of code ago now. So.
And that's the thing with Python. It seems like because it's not strongly typed and it has a lot of lax regulations, so it seems it gives more programmers a lot of leeway to do stuff, and that makes sometimes it makes debugging Python code a lot more troublesome than debugging code in other languages. Because I know if somebody were to send me a code from maybe Java or something to debug, I know, okay, if you are trying to declare a new class, it has to be maybe dog, my dog equals to new dog, stuff like that. But in Python, it becomes, because of how free the language is, so you have to sometimes try to even understand what the person is trying to do, and then and like sometimes we have bad programming practice. Like me, sometimes I'm so much in a hurry to write code that I don't write comments, I don't write doc strings and stuff like that. So sometimes looking back at my own code, I get to now try to think, okay, what was I doing here? So yeah, it's a problem. But I think maybe what would not happen is, in order to ensure that we don't become bad programmers, we might just have to now make it like a lifestyle to always have comments and doc strings. What do you think that?
I believe that, so it's interesting, in a strongly typed in strongly typed languages, you don't have to do the good programming practices of indentation that Python absolutely depends on. You can write code that's so clean with very well described variable names and function names that it needs very little commenting. But it's still good to comment your code. It's still good to put in documentation of how this huge class works. If you really want to learn to code Python classes well, look at the source code to scikit-learn. The kind of stuff I've been mentioning about cohesion, which is meaning you don't do just a whole lot of things in one function. You have methods or functions that do specific tasks, just simple specific tasks, and you call those a lot. That's a very good programming style. In other words, what you and I are both trying to say is, if we're careful to code very cleanly, all the things that bug some people about Python are not a problem. If we follow really good coding practices, all the fears about Python are not a problem. There was even a time in the past where I thought I needed to move away from Python. And I went to a developer friend of mine and I said, hey, I want to do this application. What language would you recommend? And this was a heavy duty C++ guy. He said, you know, have you ever heard of Python? He thought it was so cool. I think it's quite instructive too that Microsoft pulled Guido out of retirement and hired him. Anyway, I wouldn't worry about it. It's powerful the way it is. All right. Any other questions? Aziz? Now, let's remember something. Let's remind each other of something. You know the disadvantage of a college class? Those people in there aren't necessarily your friends. They can be harsh. Like, I've got chickens. I've watched them for years. They'll peck on the weak ones sometimes. And there was a time where my noble border collie Ambrose would watch for it and go break it up. He didn't like it. When I was teaching at the university level, I made a rule. I said, I don't have any rules. In fact, and I had a very flexible grading structure and everything. I said, but one thing that'll get you kicked out of class for that day is if someone asks a question and you're not polite to them for it. Or if you're rude to one another, I'm going to kick your ass out of here. That's the one way you can make me mad. Now, however, we're family. So you might have questions that you're a little embarrassed to ask in a normal setting. Please know you don't have to be embarrassed to ask it here. So, is there anything we went over that you want to ask some questions about? Without fear.
Okay, can I go ahead?
Yeah, let's hear it, Anu.
Can you go on the cool mixture?
Oh, you know what? I just now saw your question in the comment. CLS is kind of like using self, but in the sense of where we're not creating an instance of the class like in the factory approach. So it's like we're only going to ever use the class definition itself. And yeah, it's like self, but when we don't create instances of self. Oh, and did that? And now, Anu, I was answering your question in the chat. Did you have an additional question?
Yeah, it's on the cool mixture.
It's on, say again?
On the cool mixture.
Oh, the cool mixture. Thank you. Let's go down there. Yeah.
Okay, so the part where you put print person 2.age. I was thinking, shouldn't it be dot year, since under your class methods you put name, comma, year?
Well, let's think about it. Here, person one is an instance of this whole class. It's just an instance of it. And person two is an instance, is saying it's only calling it now, it's treat. Person two is actually just a reference to person. Now this is interesting. Okay, it's creating a new instance of person, but it's calling the class method. And then that, yeah. So, okay. Now, what's your question?
I think what caused that is because in the process of instantiating person two, the reference was to the method that person does from birth year.
I kind of don't like the way this was done
That's
in this case, because what it's doing though, it's passing it in directly.
Exactly.
It's passing it in directly.
Mm-hmm.
So it's saying, I'm going to create it. And yeah, it's really kind of weird because it's going straight to creating an instance and using this class method. And I think this was meant to be an ultra simple example, just to show a mixture of instantiation, class methods, and static methods. And for that, to show how they work differently, it's great. And certainly because of the way this is being used, you can do this because it's really just bypassing this. In other words,
I think it's cool because instead of passing, because normally the what we should have passed was self and like name and the age, but now because we are calling that method from birth year, we can pass the name and the year, and in that process Python would run that and return the age. So when you call person.age, Python will be like, okay, it's like superimposes that over the original variable that should have been there.
Yeah.
No, I get why it's giving me the age when you do print person 2.age, but what I'm asking is under the class method, we have name and year. There's nothing like age. But why is person 2 having age there?
Oh, because that's a good question. Hang on a minute. Person 2.age. Let me think. That's a really good question. Okay. Ooh, now I really get why you're asking that. Oh, this is a good question. Because in my mind, this is creating both an, okay, it didn't create an instance, I think, but then, oh. how did that year get set? That's exactly right. Or that age.
That I think it also has to do with the decorator, because there is a decorator on that function from birth year, that
Oh,
class
no.
method.
Absolutely. But I get a news question. Where for the instance, for the person to instance, where did age get assigned?
That's
We
it.
never,
Because of that decorator there, that's at class method. Whatever code makes up that decorator is probably pointing this from birth year and trying to create something like a superimposition so that when you call that at the point of initiation, you can actually pass in the birth year. And then when you call the age.
oh, it's because of this. I kept missing that. You see how it's using CLS here?
Right.
It's placing this calculation into the age right
exactly.
here.
Exactly.
I kept overlooking that. This right here is key. And that is clever. It's like saying, oh, I don't know my age. Well, what year were you born? We figure it out. So that is really cool. Yeah, it's saying, okay, return, it's returning the class. It's returning a class instance. Because this is what is needed to provide the instantiation. And so that, oh wow, that's really clever. I'm so glad you asked that, because I looked right over that. Very cool. Okay. So glad you asked that.
And again, it goes to show the same thing I was talking about, because Python allows you a lot of space for creativity. And
yes,
sometimes it can be a bad thing, especially when you're going to have to debug a code like this, because already now to debug this code, especially if you had not looked at this, you probably would have spent 1 hour. You know, me, I would have spent like an hour looking at this code and trying
I think we definitely learned more together than me just teaching and you guys listening.
True.
Because I literally, I was not very focused on that's all wrapped in parentheses, and this is a good example. And this is a great example of staying curious and experimenting too. Well, Anu, thank you. Excellent.
All right. I think Shruti has a question and Aziz has another question. So Shruti, let's go.
Yeah.
Shruti.
Oh,
she just disappeared on us. Okay. I think she
I think it was her connection.
Yeah, connection. Yeah. Okay, Aziz, please go ahead.
Aziz, did you have a question? Oh, go ahead. Oh, it's so quiet. Can you put it in the chat? It's really,
it's really low. Really low.
I don't know why. I know. I bet it is. We can be patient with your typing though. Dolly, while he's typing, oh, never mind. I just want to contribute. About the bugging. Ah, okay. So one thing I find helps a lot is I code in small steps and test. And I really make sure that amount of code is doing exactly what I want it to. And sometimes I assume and move ahead that, oh yeah, do this, do this, do this. And then I have to backtrack to do what I just said on stuff that I thought was going to work. And in fact, I'm working on a NLP project just for fun. And the data was really dirty. In fact, it was the Urdu language from Pakistan. And oh, it's tough. Okay. Ain't working again.
Okay, Aziz, I think you can share the link to the notebook, the collab you worked with. You could put the link to the collab, and then I'm sure before we go, we could look at it together. Is it the same collab you submitted? You sent it to us? All right, okay, so maybe I should just put the link then. Let me.
And when he says he's using Jupyter Hugo, does he mean Colab?
Yes, he sent a copy to me in collab. So let me just put the link.
Yeah, great. We can try to open it.
Okay, I open. Okay, I'm just going to copy the link.